Question 30. Constant element, aluminium and boron. Write electronic configuration. What is the number of valence electrons? What are the possible values of quantum numbers for the last electron? Indicate whether the electronic configuration to 5. We have to place 5 electrons. So it's electronic configuration 1s2, 2s2, 2p1. For aluminium Z equal to 13. Its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p1. Valence electron for boron. So we need to look on the last shell. Last shell n is equal to 2. Electron in n is equal to 2. We have 2 electron plus 1 electron. 2 electron in s2, in 2s2, and 1 electron in 2p1. So if we add the 2 plus 1 electron, then we get 3, which means we have valence electron for boron equal to 3. For aluminium, also we look on the last shell. The last shell is equal to 3. N is equal to 3. Then the N is equal to 3, which is the last shell, has 3 electrons, means 2 in 3s and 1 electron in 3p. Then aluminium has also 3 valence electrons. What are the possible values of quantum numbers for the last electron? Last electron in boron, n is equal to 2. If n is equal to 2, L vary from 0 and 1. Then for L is equal to 1, we have m is equal to minus 1, 0 and 1. So that is where we have p orbital. Because for L is equal to 0, in that case we have s orbital. Then the electron is located in p orbital. It means if the last electron is located in p, we have L is equal to 1. Remember, when L is equal to 0, we have s. When L is equal to 1, we have p. When L is equal to 2, we have d. And when L is equal to 3, we have f orbital. Then after getting m, s is 1/2. This is the quantum numbers for this last electron of boron. Going to aluminium, we also look for the last electron. Last electron n is equal to 3. L, it is located in p, meaning that L is equal to 1. M, if L is equal to 1, then m is equal to minus 1, 0 and 1, and the s will be equal to 1/1/2. When you have s, L is equal to 0. When you have p, L is equal to 1. When you have d, L is equal to 2. And when you have f, L is equal to 3. Then for the 1s, it means n is equal to 1. And because we have s, it means L is equal to 0. So that is 1. N plus L is equal to 1. Going to s, n is equal to 2. S is equal to, for s, L is equal to 0. In that case also is 2. Then n plus L rule for 2p, we have 2 as n. Then because we have p, L will be equal to 1. 2 plus 1 is equal to 3. Then the order 1, 2, 3, so this is respected because the first one, 1s is filled, followed by 2s, followed by 2p. So meaning that this is boron, the configuration of electronic configuration of boron is not violating the n plus a rule. Let's check for aluminium. For aluminium, we have 1s. So n plus a rule for 1s, it will be 1. Because for s, L is equal to 0. Then 2s, it will be 2 because for s, L is equal to 0. Then for 2p, we have 2 as n. L will be 1. Then we have 3. Then for 3s also we have 3 plus 0, which will be 3. Then for 3p, we have 3 plus 1, which will be 4. L for 3p, L will be equal to 1. N will be equal to 3. Then adding 3 plus 1, we have 4. So this is also not violating the rule. Not violating the rule because the filling order is 1, 2, 3, 3, 4. So there's a 3 we don't have any conflict because the 1, 3 is for 2p and 3s. And remember, the one with n, the lowest number of n is the one which is filled. So which means 2p is the one filled before 3s. Because 2 has a lower n than 3s. So in that case, then this is not violating the n plus a rule. Explain why the following electronic configuration are not valid and provide the correct electronic configuration. We have 1s2, 2s2, 2p6, 3d3. So the correct order should be 1s, 2s, 2p, 3s. 3d cannot come before 3s. For z equal to 13, the correct electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p1. Then for the II, so we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4d10, 4p5. 4d cannot come before 3d. That is where is the problem as the correct electronic configuration. So that's all for this question. Now, indicate the principal quantum number and show how many valence electrons do each of the following elements have. We have calcium and oxygen. Looking on the calcium, we draw the electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Then n is equal to what will be the value of n. Then what will be the value for valence electrons? N is equal to 4, n is the last share. We have n is equal to 4 as the last share. Then valence electron, we count the electron in the last share. We will be having 4. We will be having n is equal to 4. And then we have 2 electrons in 4s. So which means valence electron is equal to 2 and the n is equal to 4. For the oxygen, z is equal to 8. The electronic configuration will be 1s2, 2s2, 2p4. N is equal to 2 as the last share. Then how many electrons do we have in the last share? We have 6 electrons. 2 electrons in 2s and 4 electrons in 2p. Identify element with the following electronic configuration. So Z is equal to 26. The element is iron. Then another element Z is equal to 45. The element is rhodium. Z is equal to 16. The element is sulfur. And Z is equal to 38. The element is strontium. So when we are talking about Z, we are counting the number of electrons in the electronic configuration. The atom of an element M of atomic mass has the following electronic configuration. We have also the atomic mass. Then, in which group and period does this element belong? Give a reason for your answer. How many electrons are in K, L, M, and N shell? Represent the characteristic of the last electron using quantum number. Now, as we are having the electronic configuration, we can determine group and period. So this is group 5 based on the 5 valence electron. When we are counting the valence electron, we are counting electron in N is equal to 4. We have 4s2 and 4p3. In that case, we have 5 valence electron. The period, we are in the 4th period because we have N is equal to 4. The second one, II, is asking how many electrons are in K, L, M, and N shell. We have 33 electrons. K will have 2 electrons. L will have 8 electrons. M will have 18 electrons. And N will have 5 electrons. Represent the characteristic of its last electron using quantum numbers. We can say the last electron is the one which located in N is equal to 4. L is equal to 1 because we have P, the last electron is located in P, and then M will be equal to 1 and S will be equal to 1 over half. When we are representing M, we are talking about if L is equal to 1, M is equal to minus 1, 0, and 1, which means the last electron is located in M is equal to 1. The atomic of element M of the atomic mass has the following electronic configuration. In which group and period does this element belong? Give reason for your answer. How many electrons are in M and N shells? Calculate the number of neutrons. Represent the characteristic of the electron using the quantum number. So this is the question like previous question. So the group, of course, in this case, we are going to have the group based on the valence electron or the number of valence electrons. So the number of valence electrons then we count in N is equal to 4. We have 5. 2 in 4s and 3 in 4p. If we add them, we have 5, meaning that it is located in the fifth group. The period is 4 because we need to check the last shell. N is equal to 4. The highest principal quantum number is 4. In this case, we will put 2 electrons in K, 8 electrons in L, 18 electrons in M, and 5 electrons in N. Calculate the number of neutrons. As we know, we have the atomic mass. If we have the atomic mass, we know the atomic mass equal to the number of neutrons plus proton. So then the number of protons, in that case the number of protons, they are equal to the number of electrons, which is equal to 33. So we counted the number of protons based on the number of electrons. You have 33 electrons by counting 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 3. So we are counting the electron based on the electronic configuration. Remember, the number of proton equals to the number of electron. Then number of neutron, we take the mass, atomic mass 75 minus 33, which is the number of protons. Then we get 42 neutrons. Then for the last electron, N is equal to 4 as the last shell, 4s squared, 4p3. So which means the last N is equal to 4, N is equal to 4, A is equal to 1 because the last electron is located in the 4p. Remember, when you have P, you have A is equal to 1. Then M will be equal to minus 1, 0 and 1. So meaning that the last electron is located in 1. Then S is the spin quantum number. Spin is equal to 1 over a half. Find the electronic configuration of elements. Z is equal to 42 and Z is equal to 43. Give the group, column, and period in the periodic table. Then you need to justify your answer. What do you find which is unexpected? This Z is equal to 42. So this is the electronic configuration. The element is transition metal. The column of the element is 6. Indicated by 5s and 4d electrons. Because when it is transition metal, we combine 5s and 4d electron. 1 plus 5 is 6. The period of the element is the fifth, as shown by the highest principal quantum number. N is equal to 5s. You can see 5s, meaning N is equal to 5. What is the exception? Exception is that 4d becomes lower energy as compared to 5s. And 4d borrows 1 electron in the 5s. You can see that 4d has taken 1 electron from 5s. Again, we can see that 4d becomes lower energy as compared to the 5s. For Z is equal to 46, we are going to use the same scenario. The element is the transition metal group. The column of the element is 10. So 10, we have 4d10, so we need to add 10. The column is 10. Then the period of the element is 5, as shown by the highest principal quantum number because we have 5s0. Exception is that 4d borrows 2 electrons in the 5s. You can see that 4d has consumed all the 2 electrons. And 4d becomes lower energy as compared to the 5s. So this is the exception for this one. You can see that 4d borrows 2 electrons in the 5s. The 2 electrons in the 5s has been taken by the 4d. Then the column of the element is 10. Then the element, the transition metals, the column 10. Then the periodic of the element is 5 because we count n, the last n is 5. Write extended and shorthand notation electronic configuration of the following element. We have sulfur, we have chromium, and we have the iodine. What are the valence electrons? You can see sulfur extended, then we can see also the shorthand. Valence electron for sulfur, we are going to get how many valence electron? We counted the one in 3, then you have 6 valence electron. Then for chromium, this is the extended, we have also the shorthand notation. Then the valence electron for chromium, we count the electron in D and in S. In that case, you have 5 plus 1, you have 6 valence electrons. Remember, for when you are filling D, the D and S shell count as the valence electron. For the iodine, we have extended and shorthand notation. What are the number of valence electron? Valence electrons, we are counting 2 plus 5, we have 5 valence electrons. Of course, we don't count this 10 because the D is filled. We don't have to count the electron in the D as a valence electron because D is filled. You have D10 which is filled. Give the maximum number of electrons in atom that can have these quantum numbers. N is equal to 4, N is equal to 5, Mn is equal to 1, N is equal to 5, Ms is equal to 1 over 2, N is equal to 3, N is equal to 2. Then we need to give the maximum number of electrons. Let's start with N is equal to 4. With N is equal to 4, we have different values of N from 0 to 3, 0, 1, 2, and 3. Then for N is equal to 0, we have one orbital, one s orbital, then one orbital. In that case, we will have 2 electrons in one orbital. So in that case, because N is equal to 4, we will be having 4s. Then for A is equal to 1, M will be equal to minus 1, 0 and 1, means we will be having 3 orbitals. For A is equal to 2, we will be having 5 orbitals, minus 2, minus 1, 0, 1, and 2. So 5 orbitals. For A is equal to 3, we will be having 7 orbitals. Then total we have 16 orbitals. Each orbitals accommodate 2 electrons. That means that we will be having a total of 32 electrons. For each orbital accommodates 2 electrons. The total number of electrons, then we have 32 electrons for N is equal to 4. Then let's check for N is equal to 5 and M is equal to plus 1. With N is equal to 5, L can be 0, 1, 2, 3, and 4. Then for L is equal to 0, M is equal to 0. This is excluded because it does not have M is equal to 1. Then for L is equal to 1, M will be equal to minus 1, 0, and 1. So, meaning that here we don't have for this one, you have the 1 orbital with L is equal to 1 and M is equal to 1. Here we have 1 orbital with L is equal to 5 and L is equal to 1. And the M is equal to 1. Then for L is equal to 2, let's check. We will be having M is equal to minus 2, minus 1, 0, 1, and 2. So we have also 1 orbital with N is equal to 5, L is equal to 2, and M is equal to 1. Because what we are looking for is the orbitals having N is equal to 5 and M is equal to 1. Then after getting the number of orbitals, then we multiply with 2 electrons for each orbital to get the total number of electrons. For L is equal to 3, M is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3. So we have also an orbital with M is equal to 1. Then 1 orbital with N is equal to 5, L is equal to 3, and M is equal to 1. For L is equal to 4, we have also 1 orbital with N is equal to 5, L is equal to to 3, and m is equal to 1. So then, how many orbitals do we have? We have 1, 2, 3, 4. We have a total of 4 orbitals with n is equal to 5 and m is equal to 1. So meaning that we have a total number of 8 electrons. 4 times 2. For n, s is equal to 1 over half and n is equal to 5. So we need to look orbitals with n is equal to 5 and also they have s is equal to 1 and a half. So L can be 0, 1, 2, 3, 4. Then for L is equal to 0, M is equal to 0, S is equal to 1 over half. That is 1 electron. Because when you are talking about 1 over half, it means it's a spin in 1 electron. Here we are not going to multiply by 2 because they have given the spin. And the plus 1 over half is only 1 electron which is spinning, not 2 electrons. Then for L is equal to 1, m is equal to minus 0, 0 and 1. Each m, for m is equal to minus 1, we have s is equal to 1 over half. For l is equal to 0, we have also 1 over half. Then for l is equal to 1, for m is equal to 1, you have also 1 over half. So each m has 1 over half spin. So the meaning that we have 3 electrons with n is equal to 5 and s is equal to plus 1 over half. 1 over 2. For L is equal to 2, then you have M is equal to minus 2, minus 1, 0, 1, and 2. And each M has S is equal to plus 1 over 2. Then here we will be having 5 electrons. For L is equal to 3, we will be having 7 electrons. Then for L is equal to 4, we will be having 9 electrons. Here we are counting electrons because with spinning, if S is equal to plus 1 over half, we are talking about 1 over 2. We are talking about the spinning. With N is equal to 5, L can be 0, 1, 2, 3, and 4. Then for L is equal to 0, M is equal to 0, S is equal to 1 over 2, or minus 1 over 2. Meaning that you have 1 electron with 1 over 2. Because another one will be minus 1 over 2. For L is equal to 1, we have different value of M. And each M is having 2 electrons, one spinning in 1 over 2, another one spinning in minus 1 over 2. So meaning that 1 electron will be having 1 over 2 in each value of M. So meaning that you have 3 electrons with N is equal to 5 and the S is equal to plus 1 over half. For L is equal to 1. For L is equal to 2, we will be having 5 electrons. For L is equal to 3, we will be having 7 electrons. For L is equal to 4, we will be having 9 electrons. So when you add them, we will be having a total of 25 electrons. N is equal to 3, L is equal to 2. For N is equal to 3, L can be either 0, 1, and 2. L is equal to 0, and L is equal to 1. We exclude this one because it does not have L is equal to 2. Then for L is equal to 2, M will be equal to minus 2, minus 1, 0, 1, and 2. How many orbitals? 5 orbitals. 5 orbitals with N is equal to 3. Then each orbital accommodates 2 electrons. 5 times 2, then we have a total of 10 electrons.